All right, 7th grade, so I'm going to be walking you through each of these problems on the lab sheet today. So if you are watching this video, this means that you have finished problem 324 and you're ready for me to go over it with you right now, which is what I'm going to be doing. Okay, so if you have not finished problem 324, you need to pause. You need to go back, do problem 24 with your team, and then come watch this video. So when we're looking at problem 324, we're looking at some positive and negative tiles here, and it says to examine the assortment of tiles at the right, and it asks you what integer, so we know an integer is a positive or negative whole number, does this assortment represent? So when we're looking here, we know that when we see positive and negative tiles, we can start to make some zero pairs. So we want to make some zero pairs and get rid of our zero pairs. And we want to see what we are left with. And we can see that we're left with -2. So this integer that this tile represents is -2. So the next question, problem B, it's asking you what happens if 3 positive tiles are removed. So up until this point, we've worked with creating zero pairs. We've worked with simplifying expressions. We haven't worked with taking things away. So what we're going to do here is it says what happens if 3 positive tiles are removed. Well, let's take those 3 tiles that we see right here and let's remove those 3 positive tiles. How can you use numbers and symbols to represent this action and the resulting value? So we can see what we started with, which we knew is -2. And we can see that we are taking away 3. So we can see that we are taking away 3. So we started with a -2, we're going to take away 3, and we're going to be left with a -5. So we had a -2, we took away 3 positive tiles, and we're left with a -5. Now, I can change colors here and show you guys quickly. We know that if we have a -2, we're taking away 3 positive tiles, we're only left with 1 zero pair here. Once I get rid of that zero pair, I'm left with 1, 2, 3, 4, 5 negative tiles, or that's where we get our -5 from. So problem C says, what happens if 3 negative tiles are removed from the original set of tiles? So let me erase what I showed you here, and we'll start with that original set. And they would like to know what happens if 3 negative tiles are removed. So we want to take away 3 negative tiles, and then they want us to represent this using numbers and symbols. So we always want to be able to write an equation or an expression. So if 3 negative tiles are removed, well, I'm going to take 3 negatives this time, and I'm going to remove them. So ultimately, I started with, again, a -2. This is what we did up here in problem A, is we identified what does this assortment represent. We know it means -2. So I started with a -2, and now I'm taking away, so we know that's subtraction, a -3. And watch how I'm going to put this -3 in parentheses just to separate those negative signs so we don't get confused. And now I want to know, what am I left with? What am I left with? So again, I'm going to change colors so it's a little bit easier to see. These are gone. And I want to make some zero pairs with what I'm left with and simplify it. So I can get rid of all 3 of these, and I'm left with just a +1. So when I take a look at my problem down here, I can say -2 minus, or take away, a -3 will give me a 1, a +1.